Alright, I want to take about 2 or 3 minutes to look at Celery and explain why it's cool and what I mean when I talk about breaking up tasks with it and how it connects with Redis in order to do work asynchronously and get those results back and forth and update progress and say that things failed or succeeded. So we've got tubes open in VS Code, and I'm going to take a look in the server code, and we've now got a new submodule called tasks. Now it instantiates Celery, which is very simply configured by loading from our config file and parsing in the Redis options. Now it creates a namespace called tasks, and again uses the broker URL to connect with Redis, and then imports a series of tasks that I've written in order to provide GoonTube or tubes with a series of new tasks that are sort of atomic but consistently clustered, we'll say I/O effects. So for example, something like sending a mail, updating a column in a record of a database, adding or deleting a record, anything like that. If we wanted to admit an external event to the, we'll say, internal event bus, then this is where we would do it. If we wanted to do something, for example, like have tubes connect to an external API and fetch something periodically, we would do it within a task. If we wanted to, say, create a subscription to an external real-time source and take some information and regularly push it back into the event bus, then again we would create some sort of tasks to interoperate with that service. Basically, tasks give us a really good abstraction for thinking about doing work and having the results in the future and pushing off that work in a really nicely formatted JSON-friendly way. So, while we're working with languages like JavaScript and Python, where objects are first class and very easy to pass around and switch to JSON and parse and decode, Redis and Celery end up being pretty natural. So let's look a little bit closer. Here in the tasks.mail submodule, we have, using that Celery instance that we created, we've imported it here, and now we're going to use it as a decorator to compose send mail and create a Celery compatible function. But here specifically all we're doing is creating the correct post data to make a request to the Mailgun API because we've got a key and we want to use that for sending mail. So nothing out of the ordinary. We fill up our object here with the payload and use the requests library in order to make a post, and here we specify our key as being the basic HTTP auth header. If it's not a 200 request, then we use Celery's retry function in order to take the bound instance of the task itself and re-execute it 2 minutes in the future. Countdown equals 120 seconds. Another example would be, now that we can add YouTube videos to the playlist, we use the official Google's API client in order to create an instance which allows us to perform search queries or to perform video-specific info fetch. And that's what we use here in order to, again, within the context of a task, we do all the work that we need to do, and then when we're finished, if we get what we need and no errors ruin our result, then we return it. Now what's very nice is that using these Celery tasks is very intuitive and not unlike just calling normal Python functions. So as an example, so if we look back to the mail task, we'll see send mail, and its arguments are, we're just going to ignore this self for now, origin, because the self is the instance of the task, and we don't really need to worry about that. We've got the origin, which is going to be the name of the email sender. We've got the destination, which is the email it's sending to, subject and body. So in Tube's room runtimes, I have created a Lua binding function, send mail, which is going to simply run the task. Now here we'll notice that it is happening asynchronously. So sendmail.apply, this is being applied in this thread, in this particular process. So if we go and boot up tubes here, actually what I'm going to do is, in order to demonstrate what's going on, I am going to, when the user sends the message mail me, then what we're going to do is send mail from sender testing. So I'm just going to send this to me. Oops. Body. And that should be that. So what's going to happen here is this is going to, using that blocking call, hopefully send me an email in this thread anytime a user says mail me in a chat message. So start up tubes. Visit our local copy. GoonTube. Okay, so here we can see that it looks like we posted an API request from our debug log. Take a look in my inbox. Mail at GoonTube, there it is. So that was pretty straightforward, but it's not perfect. We want to look at how we can actually do this asynchronously. So we're going to go back into Tubes Room, and we're going to look at this apply again, and we're going to cancel this. And we're going to execute apply underscore async. So now it's going to fire and forget, and it's not going to do anything immediately because there's no asynchronous workers running in order to listen for the work and do it. So we'll start this up again, this time with the asynchronous mode. We'll go back here. Oh, logged in. We're going to go in here and we're going to say mail me again. Pause that. Okay, so a task has been issued, but nothing's happening. If I go back to my... Nope. So what we're going to do is get ourselves in the Python environment first. We're going to go into the server, and we are going to spawn a worker. And -a allows us to specify the app that we're going to load as the worker. And we are going to load specifically the module that instantiates Celery and loads all the tasks. And now we're going to find that, yep, it had something previously from an example I'd done earlier, and it was able to find the work and do it. Very good. So what's interesting here is that now, if we were to look at this, when you go and grab the result from this, it's not the result of sendMail, it's the result of creating a task to do the work of the sendMail, and these are the arguments that we've sort of passed in a marshaled format. And what's going to happen is we fired and forget, we don't care, but depending on the binding function we were creating and the sort of future or promise that we wanted to represent, we could also allow for a callback that when some complex saga of work had been completed in the future, then we would call back to some scripted function or some Pythonic function or whatever it is that we wanted to do. The point is that these Celery workers here, now this doesn't have to be on this machine. It doesn't have to be on this network. This allows us an excellent way to think about breaking apart and distributing work. And also excellent is Celery features great monitoring to allow us to do things like performance analysis and monitoring statistics on the work that we are doing and how we allocate our tasks. So when I was talking earlier about being able to part things out based on where performance is best, worst, where networking latency issues may come into play, those are all cool, big sciencey things that people smarter than me that are associated with tubes will hopefully be interested in playing with, as I am hoping to make cool, fun tools for looking into that stuff. Anyway, it's really neat just how easy it is to extend tubes in order to provide these new kind of I/O appendages, and I hope you found this at all interesting.